Okay, so welcome to my presentation. I'm Kishore. I'm from the Department of Bioresource Engineering, and my topic is data acquisition systems. Here, actually, in the figure, I wanted to show you just like a brief, how a data acquisition system is and what's the purpose for. This topic is actually based on the Merck reference number. In this slide, I would like to show you the copy of the tender notice, which actually tells that the client is from National Research Council for Surface Transportation Technology, and they're looking for, or the requirement is of 5 data acquisition systems. Now, before I actually start further with my talk, I would like to show you an interesting video. Okay, so I hope you enjoyed the video. Now, you might be thinking like, what is the link? Because now I'm talking about surface transportation, so that's why I wanted to show the video. Now, before actually I looked at the tender, I thought of making a few assumptions. So, the assumptions that I made was that the technology they're looking for implementing safety protocols, especially at the sides of the roads where actually the car enters the freeway. So they want to study a road traffic pattern by installing motion and speed sensors at predefined locations across the freeway entrance lanes. Now I would like to tell you the basics of data acquisition systems. It's nothing but a collective group of computer systems, sensors, data acquisition cards with some device drivers and an application software for human-machine interface. The main component is the data acquisition card, which is an electronic device to sample and log time series signals from various physical, chemical, and digital sensors. Few of the features of a data acquisition card are: it has an analog and digital inputs, it has a communication port, it samples the data at a certain sampling rate. The more faster the sampling rate, the more expensive the cards are. It has a resolution bits, more bits for more precision, and it should have a USB interface. Now, to make it look more simple, I would like to show you the block diagram of the whole process of a data acquisition system. This picture actually depicts a scenario where cars are trying to enter the freeways, which could be a danger zone if you are actually not controlling yourself properly. So that's the reason probably they want to put some sensors which can be connected to a data acquisition card, which has a USB interface. It gets connected to a computer which has a certain hardware, and it has an application software running on a certain operating system, and that's how the human can actually monitor what's going on there. Okay? So that's it. That's a complete data acquisition system. Now I would like to tell you the list of few popular data acquisition system manufacturers. The major players are National Instruments, Quantec, Edlink, Dayspace, Analog Devices. Their hardware is mostly run with Windows, and they actually also make device drivers. The programming of the human-machine interface could be done using MATLAB, Simulink, LabVIEW, Visual Studio, and the support comes by the manufacturers and the application developers. Now, when we actually go with these products, there's a price associated with the device drivers and licensing of development and deployment softwares. Therefore, the total cost would actually be the summation of all the items listed. Now I would like to talk with you about another option which is associated with the product that I want to recommend. So it actually goes with open source platform. What open source stands for? It's nothing but freedom to use, develop, modify, and build user applications and device drivers with or without any charge. There are DAQ cards available, such as USB ducts, Arduino, Micro Chameleon, etc., which can be connected to a computer under Linux, such as Ubuntu Debian, which also comes with device drivers under Comedy framework, and the programming could be completely done like free using GNU, C, C++, Java, C, Xcos, TCL, TK, or TLab. Again, the support comes from the hardware, software vendors, and the open source community. Now, if you actually go back to the total cost, it would be lesser because here we're not going to have any development plus deployment software cost, and there could not be any cost for device drivers as well. Therefore, I would like to now introduce you to my product of the DAQ card, which is USB DUX Sigma. Here's the logo of the company. Here, how the card actually looks like from inside. It has 16 number of analog inputs, 4 number of analog outputs, 24 digital inputs and outputs. It has 1 communication port. The sampling rate can go up to 68,180 readings per second. The resolution bits are 24, and it has a USB interface. Now, why I'm actually recommending this product? Because it has all the functions that are typical for DAQ hardware. It has high sampling rate and high resolution. The price is low, which is like $350 per piece, and it's compatible with open source development platform. Therefore, I would like to conclude by recommending you again that you should buy this product, because if you buy a DAQ that is compatible with an open source platform for development, you can make good savings over the cost of deployment and the development softwares. For example, I would like to show you the costs in US dollars that you could save on licensing of MATLAB, LabVIEW, or Visual Studio. The price that you can save is approximately $5,000, $5,000, $1,000, or $250. And I would like to acknowledge you all. Thanks for your attention. Thank you, Dr. Lasrid, for being a course instructor. I would like to also thank to my supervisors, and special thanks to my wife, Nita. Here are my references. If you have any questions, you can start.